the relationship between gravitational potential energy, mass of the body, and gravitational potential. So let me teach you about change in gravitational potential. Very important formula in computation. In gravitational change in gravitational potential energy. Change in gravitational potential energy. This is very interesting point. So the change of gravitational potential energy, we say that suppose that we have 2 points on the surface, on the Earth's surface, for example. So the first state, we say that consider the figure below. So what figure we have to consider? So this is the figure. Okay, so equality 1 over r, or 1 over infinity, we call it 1 over infinity. We had what r. Mass of the S, and then this is gravitational field of the S. Suppose that is the gravitational field of the S, and then we want to move the body from point A to point B. So then here we have a certain distance, we call it R1. Against here we have total distance from here, from the center of the S to point A, we call it R2. Okay, so R2. So we say that this is the S and then this is the point. So we say that the gravitational potential energy between the 2 points say it is infinity So the gravitational potential for these two cases, we say that from the general formula, our general formula there, we say that, yes. So we say so that the first state, second state, we say that we have to recall the general formula of gravitational potential, which is U is equal to negative mass of the body, mass of the S, gravitational constant, over radius r of the S. So then now we have to go to the third state. So third state, we say that we have determined gravitational potential between point A, or from point A to point B, right? So basically we might say that this is negative mass of the body, mass of the S, gravitational constant. And then for this case, we'll say that we have to take 1 over R2, which is the distance from point A to the center of the S, 1 over R2. Can use even capital letters, there's no problem. Minus 1 over R1. No square, because this is gravitational potential. So we say that what we have done there, we say that to find gravitational potential between point A and point B, we have the gravitational potential of taking a satellite from point A minus gravitational potential at point B. This is gravitational potential at point A, between the S and the body, such as the satellite, and this is the gravitational potential at point B. So remember that gravitational potential at point A is equal to negative mass of the body, mass of the S, times gravitational constant of a radius 1, radius 2. So this over radius 2. And then gravitational potential at point B is equal to negative mass, mass of the S, gravitational constant over radius 1. So that's why the gravitational potential between 2 points A and B is equal to what? Negative mass of the S, mass of the body, times gravitational constant. So that's why we say that is 1 over radius 2 minus 1 over radius 1. So now, because we have negative outside of the bracket, if we set the negative, then we are going to have the gravitational potential of AB is equal to mass of the body, this mass of the S, times universal gravitational constant, and then say what? 1 over radius 1 minus 1 over radius 2. So this is what we call the gravitational potential of the between point A, gravitational potential change, or changing gravitational potential between the two points. So it's very important because some of the problems you can solve without that formula. So you have to make sure that you bear it in your mind, and in order for you to simplify your life as well as a good student. Okay, so then few minutes I will be ending this lecture, but before I end this lecture I have to teach you another concept. I think that the seventh concept for this lecture. This lecture is comprising a lot of stuff because physics is beautiful, so you have to learn it every day, every time you go, you sing the chorus, the verses of advanced physics. It's beautiful, beautiful, beautiful. It's not tough the way you think it is. So then now I want to teach you about the concept. I didn't write in my title, okay? In the title, but I'll have to teach you about escape velocity. So in the next lecture, I'll be teaching you about total energy. Next lecture, total energy, I'll be teaching about the gravitational potential energy, kinetic energy, and total energy. Mainly kinetic energy and total energy, because I've told you about potential energy. So it's just like a matter. I think that, yes, we have to cover this. And then the escape velocity will be next. So before the escape velocity, let me teach you about other form of energy, because I've told you about potential energy. Interesting. Then now I want to teach you about gravitational kinetic energy. Okay, gravitational kinetic energy. Say gravitational, 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 kinetic, kinetic, kinetic energy. Gravitational kinetic energy. Say it again. Gravitational kinetic energy. Gravitational kinetic energy. The kinetic energy that makes bodies to move in the gravitational field. That's the meaning of gravitational kinetic energy. So it's a beautiful, it's a mechanical energy. It may be a circular kinetic energy, so it may be, it means the kinetic energy that making the satellites revolve around the sun, around the moon, around the S, etc., etc. So that's the meanings of gravitational kinetic energy. So when it will be it's making those satellites to revolve around the S, or around the sun, or around the moon, then at the same time you find that kinetic energy will be affected by the gravitational field, which I told you at the beginnings of this lecture. So that's all about kinetic or gravitational kinetic energy. So we say that when the satellites orbit around the S on the surface, the satellites possess only potential energy. When the satellites orbit around the S above the S surface, at the head. This one, the satellites possess both potential and kinetic energy. So that's the point. So it's when the satellite, in case you have questions, don't hesitate yourself to ask in the comment section. When the satellite revolves or orbit the Earth, right? Orbit the Earth, it possesses what? Both what? Kinetic energy, we call it gravitational kinetic energy, possess both energies. Possess both, one, gravitational kinetic energy, and also it possesses gravitational potential energy. That's why we are learning. That's why I'm teaching you this stuff, and even the syllabus recommended the students should know these two or these energies of the satellites. As I said, they have been learned satellites partially. However, that this is not the end of enjoying the beauty of satellites. If you pursue bachelor in engineering, especially at electronics engineering or electrical engineering, mainly electronics and telecommunication engineering, there's a module called satellite. You'll be spending 4 years learning about satellite. Interesting. Very fantastic subject, and even sometimes that it can give you some key points how do those astronomers or physicists or engineers design the satellites for communication. Okay? There's a lot of things to calculate. There's the computations of the energy. You have to find the loss, right? Because there's a loss. And then you have to think that, for example, the satellite is transmitting the signal to the Earth's antenna, which is Earth's dish antenna. So what's happening there? Okay? So gravitational potential energy. So we say that gravitational kinetic energy we say that gravitational kinetic energy, right, is the energy, right, that revolves, is the energy that revolves satellites in their orbit. So this is dynamic energy. So you have to be careful on driving this kinetic energy. You have to be very careful. So let me teach you as a physics student, or as a handsome and beautiful physics student, let me teach you how you can derive this gravitational kinetic energy. And then I will teach you about the total energy, and you enjoy the beauty of physics. Okay. So then we say that derivation, physics, advanced physics is beautiful because it's involving derivations, computations, thinking explanations, very interesting. Derivation of the formula. Derivation of the formula of gravitational kinetic energy. Kinetic energy. Interesting. So the way we derive, sometimes that's confusing because we have the fundamental formula of kinetic energy, which is a half times mass times velocity squared. So, it can make you confused a little bit, but you have to be careful. I'll be following some of the steps to derive this formula. The first step, we say that consider consider a satellite, because we know now the body, a satellite of mass, let's say M, right? Revolves the S, or revolves the S above its surface. Above its surface. Revolve the S above its surface. So let me draw the figure of what I've stated there. This is the mass of the S. And then we have the orbit of the satellite. Then suppose that here we have a satellite of mass M. So then this is the radius of the S. And this is the height, which is h, right? So this is what we call the orbit. And then what is this? This is S's surface. S's surface. So then we want to know two things. First of all, the force of attraction between the satellite and the S, right? Force of attraction. The satellite will attract the S, and also the S will attract the satellite. That's the first type of the force that experienced it there. The second type of the force that experienced at this point, also there's a centripetal force which provided by the satellite, right? And this centripetal force is always directed toward the center, centripetal force. Centrifugal force is always directed away from the center. So in order for the satellites to keep orbiting in its own orbit, means orbiting its own orbit, then that this centripetal force should balance with certain force of attraction. So we got the second step of derivation, right? Second steps of derivation. Second step of derivation, we say that recall Newton's universal gravitational law, universal gravitational equation, which we say that the force of attraction between the satellite and the S is given as this, and then radius of the S plus the height h squared. So this is the first equation. Steady state. Again, the satellite provides the centripetal force that will be balanced by centrifugal force provided by the S. So we say that consider or call centripetal force, and this centripetal force is equal to the mass of the satellite, then square of the velocity of the satellite. Then here we have radius of the S plus the height h, because that's the radius of the orbit of the satellite. So this is equation 2. So we say that, or according to Newton, the heavenly body, that is the satellites, maintain its orbit if both forces, the centripetal force and force of attraction, balances. So we go for the forces tape. For the forces tape, we say that equate, simply say that equate equation 2 is equation 1. So if you equate, you have mass of the satellite, square of the velocity, radius of the S plus height h. This is equal to mass of the satellite, mass of the S, gravitational constant, then you have radius of the S plus the height h square. So then this we can simplify, and then on the left hand side you have velocity square. We can simplify, we can leave it. So for this one we should not simplify because we need this term. So we just simplify the denominator. Mass of the satellite, mass of the satellites. We know they can cancel, but we are looking for something. So we should know where we're going. That's the beauty of physics. So on left hand side we have mass of the satellite, square of the velocity of the satellite, then mass of the satellite times mass of the S, times the universal gravitational constant, then times radius of the S plus the height h. So then this is the third equation, right? The third equation. So we have to go for the fifth step. The fifth step, we say that multiply by a half to both sides of equation 3. So to multiply by a half, multiply your left hand side, a half mass times square of the velocity times a half, then so you have mass of the satellite, mass of the S, universal gravitational constant, then radius of the S plus the height h, like this. So what does this mean? So it means that from mechanics, especially Newton's law, or from the fundamental mechanics, kinetic energy is always equal to half times mass times square of the velocity. So if that the case now, we say that the gravitational potential, the gravitational kinetic energy, gravitational kinetic energy, gravitational kinetic energy, this is given as products of mass of the satellite, mass of the S, gravitational constant, over twice, right? Twice of what? Radius of the S plus the height h, like this. So this is what we say the kinetic, gravitational kinetic energy. So that's the form of gravitational kinetic energy of any heavenly body. Question. So then, if a satellite at its orbit possesses both kinetic and potential energy, I would like to challenge you before I answer that question. What do you think now? We might have something called the total energy, right? The total energy will be the summations of all the potential energy and kinetic. So please, can you spend short time, just can pause the video, and then write a formula for the total energy, just like your homework. Okay? So then the concept now, we want to know the gravitational total energy of the satellite. That's a very important point. Right now, we have to make sure that we cover it before we end this lecture. Okay? So yes, kinetic energy, so everything is correct. So then we go now to derivation. Derivation of what? Of gravitational. Derivation of gravitational total energy. Because we say that the satellite possesses both potential and kinetic energy when it is orbiting the Earth. So derivations of the formula, derivation of the formula, excuse me, for you should not write, just you add the missing words. Derivation of the formula of determining gravitational potential, excuse me, please, gravitational total energy gravitational total energy. So we say that a satellite possesses both. So when, let me repeat this sentence, very important, very powerful sentence. When a satellite revolves the S or any other planet, any other planet or any other star, it possesses both potential, gravitational potential energy, and kinetic energy. So now, the gravitational total energy, gravitational total energy which is the total, this is given as we have the gravitational potential energy plus kinetic energy at the formula, right? So gravitational potential energy is equal to gravitational potential energy, which is negative mass, the mass of the S times gravitational constant over the radius, which is radius of the S plus the height h, and then this one plus kinetic energy, which is products of mass of the S times gravitational constant, okay, divided by 2. Then we have radius of the S plus the height h. What do you get? You have -1 plus a half. So because you have -1 plus a half, the answer will be -1/2. So if you find total energy, if you find the LCM, it will be what? It will be twice radius of the S as the height h. So take this LCM divided by this, we get -2 mass of the S, mass of the satellite, gravitational constant, plus take this LCM divided by this one by the numerator, so plus mass of the satellite, mass of the S, times gravitational constant. So the total energy for this case, we say that this plus this, we get negative. So it should be negative mass of the S, universal gravitational constant, and then you have 2 radius of the S plus 8h. So this is the general formula of total gravitational energy. What does it signify, or what does it indicate? It means that the total gravitational energy is equal to the negative gravitational kinetic energy, also is equal to a half of potential energy. So to get this fact, you have to relate all the 3 formulas. You'll find that this is fact, this is the truth. Okay? Okay, so those are very important formulas. You need them in order to solve problems in physics, and especially regarding about potential energy, kinetic energy, total energy, gravitational field strengths, gravitational potential. So a lot of them. So you should make sure. That's why I tell you that I will never teach you to create the formulas. I will be teaching you how to write them, because that is powerful. And even myself, I don't remember all of these formulas. I cannot keep this in my brain. I fail. So that's why I know where should I start to derive. So then to end this lecture, I would like just to leave the homework. So this is, I know that now students are very happy. They are very happy when now they hear a phrase or sentence that the homework number 8, because it's the end of the lecture. However, that they have a lot of things to cover, but they say that at least for today, I've ended or I've reached the end of lecture 8. So the homework 8, I would like to leave 2 simple questions for you who is good in gravitation. The first question is, describe briefly the meaning of escape velocity. Escape velocity. The second question, derive the formula, mathematical formula, derive the formula that determines the escape velocity, escape velocity of what? Escape velocity from or above the Earth's surface, or escape velocity above the Earth's, above 1, Earth's surface, and then 2, any planet's surface. So make sure that you do those 2 questions of the homework of lecture or session or period 8. And this is the end of our fantastic lecture or session or period 8 of gravitational mechanics. We have been learning a lot about the potential. Just to summarize what I've taught you. I've taught you about the meanings of gravitational field. I've taught you about the meanings of gravitational field strength in its mathematical formula. I've taught you about the meanings. I've taught you how to derive the work done required to bring a body from the infinite regions to the point. I've taught you about gravitational potential. I've taught you about gravitational potential energy. I've taught you about the relationship between gravitational potential and gravitational potential energy. I've taught you about the gravitational kinetic energy of the body. I've taught you about the total or gravitational total energy of the body, or especially the satellites. And then right now I have left the homework for you to go through or to read about the escape velocity. So join me in the next lecture. I thank God who have been preparing me since long time. It's almost that he's been preparing for more than 11 years talking about this stuff. So I learned this stuff more than 11 years before I taught you. Okay, so God has been faithful. He gave me the power, He gave me the understanding, He gave me the different techniques and different teaching aids to deliver this message or to pass this, what I know about the gravitational potential, gravitational field, or gravitational energy. I've passed it to you. And I thank God also because I believe that you have been grasping everything that I've taught. And I would like just to thank God again because I believe that He'll be faithful and will give us a chance to continue on lecture 9 of gravitations and possibly even lecture 10 of gravitation. That will be the end of gravitations and everything. So make sure that in case you have any questions, you can watch this video several times. If you find that maybe I've been teaching quickly, you can pause it and then you can repeat it several times. And then in case you have any questions, please ask in the comment sections. Make sure that you also read the descriptions. And in case that you feel from your heart that you want to offer your free willing thanksgiving like the one that I'm offering to my nation, then you may use that phone number, that is 0759 74 53 31. And then share this material with your colleagues, with your classmates, with the pre-Form 5, with the Form 5 students, okay? With the Form 6 students. I believe that it will help thousands and thousands of the students. And When you have been watching, please tell us in the comment sections in which regions are you come from, because we want to know that where have we reached it already and where we haven't reached it yet. So I would like just to ask you that join me in the next lecture. This is the end of lecture 80. May God bless you.